more complicated ones. Definition of a polynomial, in case you forgot or you never knew. A polynomial function is an expression in which all exponents of the variable are whole numbers. So an example could be something as simple as x squared. That's a polynomial. We could have x cubed plus x minus 7. That's a polynomial. We could have 3x to the 8 plus x to the 5 minus 8. Totally just making that up out of my head. Those are all polynomials. Why? Right, so what it means is that you don't have any fractions in the exponents. Because we know way back from grade 10, if you have a fraction, that's actually a root, and we did radicals last unit, so we've actually already covered them. That's all it means, is that the whole numbers are exponents. Today we're just going to look at division. Again, it's theory to be able to graph. One of the first steps you do when you're graphing is divide, so we're just going to practice. I used to use paper because I was trying to save on some photocopying. And so we're going to take these gigantic, scary-looking polynomials and divide them by stuff. So the first one's dividing f of x equals x cubed minus 3x squared plus x squared minus 3x plus 4. So for some eyes and some kinds of brains, I'm going to bracket that just to show you that's what we're dividing by x minus 1. And just a reminder from what you started talking about in grade 9 is dividing or factoring is the opposite of multiplication. That's why we do it, is we're trying to work backwards. This question is asking if I take x minus 1 and times it by something, I want to get this. So we're working backwards. What's the something I times by to get this big whole expression here? Well, how do we divide polynomials? Well, we already learned it last unit. It's called synthetic division. Walk me through synthetic division. I heard somebody say a 1 on the side. Tell me why. Because x minus 1 equals 0, and we solve for x. X equals 1. So that comes from the binomial that we're dividing by. Yep, the coefficients of the polynomial. So the first coefficient we see is the next one, the next one, the one after that, and the very last one is? Okay, walk me through the rest of it. Waiting. Bless you. Any questions where those numbers came from? There's going to be a note in the next example that will talk about the order. Now, what we talked about with oblique asymptotes is this was always y equals mx plus b. And the reason that was is because this up here was always quadratic. We were dividing a quadratic, so what you get out is a linear function. Whatever you're dividing into, you get 1 degree less. So we were dividing into an x to the 4, so this is going to start with x to the 3. So this represents 1x cubed. This represents negative 1x squared. The 0 represents 0 x's. The constant is negative 3. What's the 1 at the end? That's the remainder. So if we take our x to the 4 minus 2x cubed plus x squared minus 3x squared plus 4, and we divide by x minus 1, we just slap this all together. We get x cubed minus x squared minus 3, remainder 1. My purple pen is dying. It makes me very sad. That's it. That's division of polynomials. Just a note when we talk about the remainder is sometimes we'll write it a little bit differently. We'll write it as a fraction. So we'll put that it's 1 out of the binomial, which is x minus 1. Your choice how you write it. You just need to be able to recognize this because that's the way the book gives a lot of answers. So this just comes from the binomial that we were dividing into the polynomial. Okay, so remainder of 1 or 1 out of x minus 1 is the exact same thing.
So the denominators and binomials that we are dividing by and the numerators, the remainder.
Correct. How are we doing so far? Like nothing, no reaction, nothing. Like thumbs up, thumbs down. What's going on?
We're just tired.
I see you're a little bit tired. Note for example number 2. Turn and talk, 30 seconds. What's different between example 1 and example 2? What's the difference besides there's different numbers, which obviously, what's the big difference between, ooh.
The units that have like a greater power in different spots as opposed to in order like normal.
Yeah, so make sure that the order of the polynomial must be from highest to lowest. So Shaz, when you asked, do we just give it the order we're given? No, it's just the first one was in the correct order. So we're going to want to rewrite this giant polynomial. What's the highest order? What's the biggest exponent? 4. So x to the 4 is going to come first. What's the next highest exponent? So negative 2x cubed will come second. After that, negative 8x squared.
So the signs in front of them don't change. They stay where they are.
How do we determine the order of a polynomial? What determines the order? It's like the same thing as the degree. How do we determine the degree of a polynomial? It's the highest exponent, so coefficients are irrelevant. Okay, after the x squared comes plus 2x, and then, and the reason the constant comes last is because that's really an x to the 0, and what's x to the 0 equal to? 1. That's why it's the lowest, the constant is last.
So does it mean x to the negative 0 is
No. Are we good with the notes? Okay, so it just means when we set it up, we just need to be aware that things are in order. What's going to go on the outside? The inside, we just talked about the order, so 1 will be first, followed by negative 2, followed by negative 8, followed by 2, followed by negative 1. That's the most common mistake I see, and I don't know why. It always happens with the last number. Something in your head wants to subtract. Okay? And a few of you did it with the oblique asymptote on the tests. I don't know. It's something in your brain wants to subtract, because I see this all the time. How is it? It's not. That's what I'm saying. It's not. What should be there? 7. Again, that's the biggest mistake I see. There's something in your brains you want to subtract the last number. Yes. Remember, the answer starts 1 degree less than the question. So if the question starts with an x to the 4, the answer starts with x cubed. So we have 1x cubed plus 2x squared. I don't have any x's, so I don't need to write that. Plus 2, remainder of 7. And I'm just going to write it over x minus 4 because it's the way the book is going to write it. Take a look at example 3, turn and talk. What's different? We're not going to do it because it's not on the exam anymore. Out. Why would you do it when you have this? Okay. Yeah, I like it that, I mean, I get the process behind it, but this is so much easier.
Germany, we had like way too complex way to solve these.
We used to do it that way, and now we stop because this is so much easier. Question, answer, pause. Okay, what's the note going to be about? Andrew thinks he has it.
How in the second term of the question, the x has a coefficient.
That is something that's different, but it's actually not going to change our process. There's something in the polynomial that's different. Go for it.
So because there's no like squared or x, we're going to assume there's 0 probably.
So we call those missing terms. So be aware of missing terms. Use a coefficient of 0. We did this with oblique, we just really didn't talk about it. Missing terms mean anything between the highest degree and the constant. So if there's anything missing, we're going to put a 0. So we're going to start with our 8x cubed, because that's the highest exponent that we have. What's missing in the middle? Well, I don't have any x squared, so I need to keep a 0. I don't have any x's, so I need a 0x. And then I would follow up with the constant. These are the two things you need to watch for, the order and missing terms. So inside I'm going to have an 8, a 0, and a -1. What the heck's going to happen on the outside? Well, we do what we always do, equate it to 0 and solve, so don't let the coefficient throw you off. How do I get rid of the -1? How do I get rid of the coefficient? So x equals. And a half's a number. We're okay with that. We're fine with that being on the outside. Process isn't going to change. I'm still going to drop the 8. I'm still going to multiply by the guy on the outside. What's a half times 8? Add vertically, 0 plus 4. 4 times a half. 0 plus 2. 2 times a half. -1 plus 1. What do I start with? Well, it matters what the question started with. What was the highest degree in the question? 3, so this one's going to start with a x squared. So I have 8x squared plus 4x plus 2. What does this 0 over here mean?
0 remainder.
And what does it mean if something has no remainder?
Nothing.
It divides evenly. There's nothing left over. That's going to become important tomorrow. We don't write remainder of 0. We just leave it. This shows there's no remainder because there's nothing after the polynomial. On the exam, that would be a half mark off. Yeah. Because just like when you divide 5 into 20, you'd never say 4 remainder 0. Right? We'd say 4. It goes in 4 times. Same idea. Yeah, we wouldn't. We just wouldn't do it. Check the order, check for missing terms. Order, missing terms are the first things you want to look for. What's our order like in question 4? It's good. Any missing terms between the highest and the constant? So this is just a straight up division kind of question. What goes inside? What goes on the outside? Finish it off. What's the answer?
Or x squared plus 9x plus 15 over x minus 2.
Who got it? Awesome. Turn and talk to number 5 together. Now let's read to understand. What's it about at this point? What have you gotten from your first read to read?
Volume of a box.
It's the volume of a box. There's something going on with a box. Okay, so volume is clearly important.
Rectangular box.
What's a rectangular box?
It means it's not a perfect square. But I guess, all right. I don't know.
It's just a normal box. It's like the Kleenex box on my table. It's like the cardboard box at the front. Why is that important to mathematicians? Well, because in theory, boxes can be any shape. They don't have to be rectangular. They could be triangular. They could be trapezoidal. Ooh. They could be pentagonic. I might have made up that word. They could be hexagons. In your world, a box is a box. Okay? But in a math world, it can be any shape. They have to tell you what shape it is. Clearly, all the polynomial stuff is going to be important. Hello. Yeah, up in the bucket there. Something about possible dimensions for length and width, and something about the height. So I heard somebody say, well, let's just take those and divide it. Well, sure, that's obviously what we're going to do because it's in this section. But if this was an exam question, you need to know why you're doing it. Because it's not going to say, hey, division of polynomials with a little arrow pointing to the question. So yes, clearly it's going to be a division. Well, why? What do we know about the volume of a normal kind of box? So volume equals length times width times height. Do we know any of those right at this point?
Yes.
Which one do we know?
Height.
Okay, we know height, so I'll put that at the back as x minus 4. Do we know the height? Or sorry, the width? No. Do we know the length? No. Do we know the volume? Okay. What's the volume?
X3.
Please do not say x3. Please do not go to university and say x3. And if you do, do not tell them I was your teacher. Thank you. Tell them you were homeschooled. Just tell them that. What are we trying to find? Length and width. So what that means is algebraically we need to get them by itself. How do you get rid of a multiplication by x minus 4? Oh, divide by x minus 4. That's okay. We'll deal with them in a second. We'll deal with them in a second. This is a division. The only way you know how to do division is synthetic division. So let's pull that out. What goes on the outside? What goes on the inside? Did you check the order? Did you check for missing terms? Okay, drop the 1. 4 times 1. 3 plus 4. 7 times 4. Negative 36 times, or plus 28. 4 times negative 8.
Negative
32 plus minus 32. Okay, what's the answer from our division?
X squared plus 7x minus 8.
And just carrying down what we had on the right-hand side, we know that's length times width. Now we need to find what are two things we can multiply together to get x squared plus 7x minus 8. What's it called when we want to find what we multiplied? We're going to factor.
X plus 8 minus, and x minus 1. I don't know, I'm just not going to factor this year.
Agree? So that means the length could be x plus 8, which means the width would be? Or the length could be x minus 1, and the width could be x plus 8. So didn't we just divide? Sure, but do you understand why we did division? Because there could be a question like this on the exam where it's not going to say divide me. How are we doing? Page 7 is the homework. Questions are on the calendar. Again, what we're doing is theory to be able to graph, so just keep in your mind